This lesson is on 10.1 exponents. Example 1. The expression 3 to the 5 is called a power. The base is 3 and the exponent is 5. A power is a product of repeated factors. The base of a power is a common factor, and the exponent of a power indicates the number of times the base is used as a factor. So in this case, the 3 is a base, and the 5 tells us how many times the base number is written. Since it's to the 5th power, we would write the base 3 5 times. So here's 1, 2, 3, 4, and 5. And then we will multiply each of those to figure out what is our final answer. So I'm going to go ahead and multiply 3 times 3, giving me 9, and then do these 3, giving me 9. So 9 times 9 is 81. But I still have this 3 that I haven't used, so I'm going to go ahead and multiply this 3. But with 81 times 3, I'm going to use an area modeling so I can work that out. So here's our area modeling, and we have is 80 and 1 and 3. So 3 times 8 is 24, but because 80 has a 0, we're going to add that 0 in there. And 3 times 1 is 3. So when we add the two areas together, 240 plus 3 will give us 243 as our final answer. In example 2, we are writing each product using exponents. So now we're going backwards. We're having this written out for us, and we need to write it in exponent form. So since we have parentheses in each of those -7 bases, I'm going to go ahead and copy that as -7, and there are 3 parentheses, so the exponent tells me I should have 3 as my final answer. Example 3 says evaluate the expression, so we're going to go ahead and work this out. Now notice this problem is a little different from the previous example 2. I have a base of -2 and the exponent is 4. Now the 4 belongs to the base of 2 and the negative is by itself, whereas in example 2 I had the whole thing in parentheses for the -7. So in this case, we're going to go ahead and write this out as negative, and we are only taking 2 for the base and writing it 4 times. So that's 1, 2, 3, and 4. And since we're evaluating it, we're going to go ahead and multiply them out. So 2 times 2 is 4, 2 times 2 is 4, and 4 times 4 is 16, but don't forget the negative, so it's -16 as our final answer. Example 4 says evaluate the expression. So in this case, because we have a mix of different operations in here, we're going to use the thing called order of operations. So for the order of operation, we're going to use the parentheses, the exponent, multiplication, division, addition, and subtraction. And we're going to check to see which of those would apply. So in my first case, I do not have anything for parentheses, so I'm going to go ahead and skip that. I have exponents, so I see an exponent right there, the 3 to the 2nd. So 3 to the 2nd, as we learned, means that we're writing the base 3 and we're writing it twice. So 3 times 3 will equal 9. So let me go ahead and rewrite this problem now as 2 plus 7 times, and then the new number is 9. Now I'm going to the next order of operations. I see there is a multiplication, and the multiplication is 7 times 9. So 7 times 9 is equal to 63. So now we're going to go ahead and rewrite the problem as 2 plus 63. The next order of operations says division. I do not have a division, so I'm going to skip that one. The next one is addition, which I do have. So we're going to add our 2 plus the 63, and that should give us then 65. And there is no subtraction, so we are done with this problem with our final answer as 65. So that is the lesson for exponents.